All right, this is 5.2, day 1, part 1. Today we're going to verify trig identities. There are some steps on this smartboard. You don't need to write them down on this first slide. So what we're going to do today is we're going to give you an equation. A right side of an equation and a left side of an equation. And these equations are equal to each other, but they don't look like it when they start off. There'll be, some type of trig stuff going on the right, some type of trig stuff going on the left. And what you want to do is start with one or the other side and continue changing it until you get the two sides to equal each other. So you start with one side only. And you keep replacing with the identities from your gold sheet. Here are some tools for you. Work with one side of the equation only. You don't need to write this down. We'll get enough practice today. Most of the time, it's the left side. Most of the time, it's the more difficult looking side, the longer looking side to work with. The next thing to help you is if you see fractions, a lot of times it's better to combine them together like we were doing yesterday. Sometimes factoring helps, like we did yesterday, to help you to see some of your identities pop up. And then squaring by a binomial or monomial denominator, I'll show you kind of what that means in an example later. Fundamental identities, those are those identities on your gold sheet. The Pythagorean identities pop up a lot. So when they talk about the Pythagorean identities, make sure you know the 3 different forms of each identity, like what we have on the whiteboard here, in the red, black, and blue. The last tool maybe is to convert the entire one side to all sines and cosines, because sines and cosine functions are the most popular of the identities that has things in it. So let's go on to our first example. It's what I do want you to write down. So here is an equation they'll give you. And the two equations don't look exactly alike. And I boxed in the right-hand side, the sine squared of theta, this piece right here. I'm going to ignore it for now. And I'm only going to work with the left side. And then I continue manipulating that left-hand side, so when I'm all done, I will get this blue box of sine squared of theta. So I'm going to replace with identities, replace with identities, replace with identities, until I'm finally done, and I get sine squared of theta to prove that these two sides of the equation are truly equal. They are identities. So we're going to start with this side. So I have some writing in the blue letters on these slides to just kind of help guide you to where I'm going with this. You don't need to write all the words down. So we're going to work with the left-hand side. Now, you want to have your gold sheets out when you're doing your assignments, when you're taking notes. See if there's something in your identities that you might be able to replace the numerator or the denominator with. Do you see anything? 1 plus tangent squared? Okay. So tangent squared of x equals secant squared of x minus 1. Do you agree? So what can I replace this numerator with? Tangent squared of theta. Yep, so off to the side here, I just put in blue writing that this numerator is a Pythagorean identity. So I can replace it with tangent squared of theta. So now my equation looks like this. Now, where might I want to go next? Very good. You may want to convert things to all sines and cosines, because in the end, I want my answer to have a sine squared of theta in it. So how can I convert tangents squared into sines and cosines? Very good, sine squared over cosine squared. So what I did is I just split up the fraction into two separate pieces first, and then recognize that this is a quotient identity, sine squared of theta over cosine squared of theta. And then on the right-hand side, I also identified an identity there. 1 over secant squared of theta is cosine squared of theta. Yep, 1 over secant is cosine of theta. So now I'm going to replace each piece with the identity. So tangent squared of theta is sine squared of theta over cosine squared of theta. And then 1 over secant squared of theta is the reciprocal, cosine squared of theta. Can anyone see the next step? Yeah. Best part ever. I get to cancel something. I get to cancel the common factor. Cosine squared of theta, cosine squared of theta. And what are we left with? Sine squared of theta. Yay, we got it. So we got it to check off that the two sides do in fact equal each other. And that's what you'll be doing in your homework today. Again, most often the time it's the left-hand side. It's usually the more difficult side. There's more stuff going on that you have to change. So let's practice another one. So verify again. And there was a hint in the beginning of our lesson today. It's a good idea to combine fractions together. So we're going to work with the left-hand side again. And when we're done, we want our answer to be a single trig function of 2 secant squared of theta. So if I were to combine these two fractions together as they are, is it possible right now? Yep, we got to find that least common denominator. So we're going to work with the left-hand side and combine the two fractions together. So what is going to be the least common denominator? What is it? The whole thing, both pieces, right? So our LCD is the 1 minus the sine of theta and 1 plus the sine of theta. There's nothing in common with either piece of the fraction. All right, so we're at this point. So now to be able to combine these two fractions together, we have to find out what we're missing. What are we missing in the first fraction from its LCD? No, because they're not, on these two fractions, they're not multiplied together. There's a plus symbol in them. What are we missing in this first fraction? 1 minus the sine of theta. Yep, so we're going to multiply the numerator and denominator by 1 minus the sine of theta. And then what are we missing in the second fraction? We're missing the 1 minus the sine of theta. Okay. Lost my connection. So I just kind of highlighted it in the green. So in the first fraction, I'm missing the green piece of 1 plus the sine of theta. And then in the second fraction, the one on the right, I'm missing the red piece of 1 minus the sine of theta. Now, are my two denominators alike? Yes. So now I can combine them into one fraction. If you're comfortable doing it all in one shot too, going from this middle step that I just showed you, down to here, that's fine also, if you don't like that middle step. All right, help me with the next step. What do I want to do next? Foil the bottom. What about the numerator? You can add them, you can clean them up. Uh-oh, I missed my connection here. I'm not able to write anything right now. We'll just finish this problem and then I'll stop the recording. So to combine 1 and 1, and then combine sine of theta minus sine of theta, what do those become? Those cancel out, and then we'll FOIL the denominator. Which 1 plus 1 is 2, and then we said the sine of thetas cancel out. And then FOIL, when you FOIL those, it's kind of like the difference of two squareds, the middle terms cancel out if it's factored form. So when we FOIL that out, we get 1 minus sine squared of theta. And then in the blue writing there, 1 minus sine squared of theta is cosine squared of theta. It's a Pythagorean identity. And then 2 over cosine squared of theta. Well, we're trying to get the final answer to be 2 secant squared of theta. So to prove exactly the same right side. So we're almost there. Use the reciprocal identity, yep. So when we use the reciprocal identity, if you don't want to separate this out, if you understand this middle step, 1 over cosine squared of theta is the same as 2 over cosine squared of theta, and reduce it there.